Hey there, class, and welcome to another week of chemistry. This week is going to be a stark kind of contrast to what we did last week, where we were working with fire and we had to kind of be careful about what we were doing. To this week, we are simply using just balloons, really. And, one of the kind of things we're going to do with these balloons is we are going to just kind of do some models of some molecules and get a little bit of facts about those. And I do want to forewarn you that while I may be a chemist, I am not a balloon maker. So for all intents and purposes, just assume that these balloons, it's a little bit better, are the same size. I'm not good enough to control how much air goes into them. I just get them inflated and call it good, okay? So just bear with me on that. I'll try to be mindful of that as I kind of go through so we don't get kind of lost in that. But let's go ahead and kind of jump into things because we're going to do a number of these. And as we keep adding on more and more kind of atoms and bigger molecules, you're gonna have to use your imagination a little bit because I can only hold so many balloons at once. But we're gonna do our best here. Okay. Anyway, so let's talk about the first kind of molecule, which is the linear molecule. You can kind of see that. So it's really just straight across here. Okay. An example of that would be carbon dioxide, where there is central atom 2 on the side. There are 2 electron domains and no lone pairs. The next would be very similar, actually, and is the bent kind of shape, where you've got a molecule in the middle and then 2 off to the side. An example of this would be like water, where where there is a lone pair causing some electron repulsion, and there are 3 electron domains. And if I didn't say that before, the linear there are 2 electron domains. Okay. So, and if you're interested in bond angles, we can talk about that too. The linear is 180 degrees, and just with that lone pair, the ideal angle to the bent model changes to 120 degrees. So, the next would be the trigonal planar, which is here, kind of like this. Okay. And then we've got, so central atom here, 1 on top. So, with the trigonal pyramidal, trigonal planar, there are 3 electron domains, 0 lone pairs, and an example of that would be like BF3. So next we will do tetrahedral, which is kind of similar here, and this is where I'm going to start kind of losing my control of the balloons, so bear with me. And it's kind of like that. So for the tetrahedral, there is 4 electron domains, no lone pairs. With the ideal bond angle of 109, about 109.5. An example of that would be CH4 methane. Okay. The next would be a trigonal pyramidal, which is an ideal bond angle of 107 degrees. And let's go ahead and do that here. It's very similar to the tetrahedral. So we've got just a slight kind of change in bond angles. This is when we're losing it. Okay. So very similar here. It almost looks exactly the same. It's a little different. And with the trigonal pyramidal, there is actually a lone pair that is attached with 4 electron domains, which changes the bond angle from 109.5 to 107. So very slight change in ideal bond angle. An example of that would be like NH3. Next, we've got trigonal pyramidal. Example of that would be like PCl5, which has no lone pairs and 5 electron domains. Okay, bear with me on the placement of the balloons. Okay, so central here. So this is central. We've got 1, 2, 3. This is attached to the bottom of the central atom here. We're going to have 1 coming out. So again, pretend this is angled downward from the central atom here. And we've got 1 on top here. So I know this doesn't look the best, but again, I can only hold so many balloons at once. Now, with that, there are 5 electron domains. There are 0 lone pairs. And then, again, an example of this would be like PCl5. So the next would be we can go all day with this, but we can go ahead and do an octahedral. Okay. Okay, so you can kind of see this. Again, so there's 1 pointing, this is the central atom here. There's 1 pointing towards me, there's 1 pointing down, and there's 3 more oriented off to both sides and towards the viewer U, and then 1 on top. And with the octahedral, there is 6 electron domains and 0 lone pairs. And an example of this would be like SF6. Okay. Okay. Let's see what else we got here. All right. So, another one we could do here, we can try to do here. We can try to do a pentagonal bipyramidal, which has 8 here, which is going to use all of these. So central, on top, bottom. Let's see, down this side. This side. Okay, we've almost got it. And then reversing this way. Okay, so we've kind of got it. The other one was on top. But with the pentagonal bipyramidal, there are 7 electron domains and 0 lone pairs. An example of that would be like IF7. Let's see, what's another one we can do here? So we've done linear, trigonal, planar, bent, tetrahedral, trigonal, pyramidal, trigonal, bipyramidal. We've done linear, octahedral. Have we done square? I don't think we've done square pyramidal. We can probably do that one. And pentagonal bipyramidal. If you look, you can see that there are a number of molecules here. So we'll quickly do square pyramidal here. Okay, central atom, one on top. And we got one to the side here, one facing me. So square pyramidal, there are 6 electron domains, 1 lone pair, and an example of that would be like BRF5. So I've gone a little over time today, but there are a number of different kind of molecular geometry shapes. So stay tuned next week for the last installment of this semester's interactive presentation, and then we'll see you again the following weeks for new, more updated presentations. So we'll see you next week, class.